Good afternoon, guys. This is the last video for week 5, entering week 6, that will summarize how to work on the Webassign on Newton's laws of motion. So week 6, there will be a video where I will solve problems using friction. There is only one problem in the assignment that uses that, and I will go over that problem on that video. The rest of the problems are very similar to the ones that we did during the lecture. So my suggestion is that you read them very carefully. For example, right? Problem 1, they give you, again, you have a puck with a velocity of 2i to the positive x direction meters per second. And 8 seconds later, you have this. So we know that there is an acceleration, which is basically final velocity minus initial velocity divided by 8. So the force will be mass times that acceleration. Okay, so pretty much, and I want to change the numbers, of course, but if you, so if you were given an acceleration of I plus 3j, and they give you a mass, which I'm going to round it to 4 kilograms, the force is mass times acceleration. That will be 4i plus 12j, and this will be meters per second squared. This will be newtons. The magnitude of the force will be the square root of 4 squared plus 12 squared, which will give me the square root of 160, right? Newtons. So that should be easy for that question. Let's try to get more out of this. So that should be it, right? This one, they give you two forces. One, they are perpendicular. In part B, they have an angle of 60 degrees. They give you the value of the forces. Find the acceleration of the object in, okay. So to find the acceleration here, right, you need to find the magnitude of the forces. When the forces make 90 degrees, you just apply Pythagoras. And that will be the force, and you divide by the mass. That's the acceleration. To find the direction, you will do F2 divided by F1, right? Arctangent. Because the direction of the acceleration will be on the y direction due to F2 and the x direction due to F1. Pretty much what you will have is a situation where if you have a force pointing upwards and a force pointing to the right, and that should be the same as what you have to do in the second part, by the way. Right? In this part is easy because they are making 90 degrees. So you have an acceleration on x, and you have an acceleration on y. So technically, the direction of the magnitude of the force, and we know that from vectors, right? That will be the magnitude. So this will also be the direction of the magnitude of the acceleration. The total, the acceleration, right? But we know that the components are AY and AX. So the direction, tangent of theta, are AY over, so the first two problems are very conceptual, right? We go back to what we did in motion but now using forces. It says, draw the free body diagram. A brick of mass M has placed on a rubber cushion of mass M. Together they are sliding to the right at a constant velocity on, okay, so they are on ice. Draw the free body diagram of the brick and identify. Okay, so that's not that bad, right? They are not asking you about the forces diagram or the free body diagram on the cushion, on the brick, but the brick is on top of the cushion. So think about a normal in that case, all right? Other than that, that should be very simple. Okay, look at question 6. I'm not gonna show you exactly all the answers, but I wanna show you the free body diagram. We did a problem like that very similar to the homework, the same with this one, right? So number 6 and 7, the lecture. Number 6 and 7 are very similar to what we did in the lecture, and it's all about forces diagrams. There will be a test on this chapter, and please remember that these are very important topics, okay? So right now, I'm just drawing here on the whiteboard the two masses. And please, once you finish with this, I want you to go into the next video, which will start introducing friction. That will be week 6. All right. It doesn't matter what. Oh, they give you the friction in this case. So let's do that. That's okay. Because you may get stuck a little bit with that. So there is friction in this problem. In week 6, there is going to be a comprehensive lecture on how to do this. So that's why this video for this Webassign is placed on the week 6. All right. The friction, kinetic friction, is equal to mu k times the normal. So when you do the forces diagram on this system, you will have that tension on the rope, that force that I'm going to give you a value of 60 newtons. I want to give this mass a value of 6 kilograms, and this a value of 4 kilograms. So the normals are basically the weights of these masses, because there's no other force acting on the y-axis, only this. So we always know gravity is acting like that. So 4 times 9.1, 9.8, that will be 39.2, right? So 39.2 newtons. 6 and 9.8, 76.8 newtons. But that is also the normal. Normal 2, normal 1. So they both have friction acting at the bottom. There is friction here. There is friction here. Kinetic and mu k, I'm just gonna give it 0.1, okay? Just to make it easy. So let's suppose mu k was equal to 0.1. That's dimensionless. So 39.2 times 0.1, the friction here will be 3.92 newtons, the force. Here will be 7.68 newtons. Now I can apply Newton's second law. Newton's second law will be for this mass that is moving to the right. So for 1, T minus 3.92 equals to 4A, the acceleration of the system. And for mass number 2, right, the forces acting are 60, but there are tension and this. So it will be 60 minus tension minus 7.68 equals to 60. So you have a system of 2 variables and 2 equations. When you do a problem, I would recommend you guys add the equations. So these equations, add them. If you add the equations, tension will cancel. And you have 60 minus 7.68 minus 3.92 equals to 10A. That's how you find the acceleration of the system. And then you can use the acceleration to find the tension. So that's how you do a problem with friction. All right. So that's an interesting problem, right? Look at the lecture video when we do more examples on that. So that's that. There's no friction here. So yeah, you can neglect friction. So this one, just look at the lecture. All right. This one, I also did it. Okay. So this one, let's see. Obviously, mass is 16 and 2 kilograms. So here's 16, here's 7. Are connected by a string. If the system starts from rest and M2 force 1 meter in this time, determine that, oh, there is friction here. Okay, that's fine. They give you the time and the distance to find the acceleration. So let me show you how you will do that problem in the assignment. So that's okay. I did combine the assignment with some friction. So that's why the Webassign is on week 6. You have this system of masses, and they give you M1 and M2 here. Don't forget that gravity is always acting. So let's put the mass values. 7 and 16. So 7 kilograms and 16 kilograms. Remember, we did this problem in the class. Tension, the same tension. But I tell you that this mass is falling 1 meter or whatever you have in your assignment in 1.33 seconds. So, pretty fix, right? We have to use kinematics because this mass is not falling due to gravity only. It's falling due to the acceleration of the system. So 1 meter, free fall, it starts from rest. Once I find the acceleration of the system, I apply on this side, I want to write the equations of motion, the Newton's second law. But remember, there is a weight and normal, and they ask you for that coefficient, right? Determine that coefficient. So you want to know mu. To determine mu, we need to know that there is a friction here. So the equations here will be, since the system obviously is gonna go like this, because of this mass, it's gonna pull it. Tension minus, what's friction? Mu times the normal. But the value of the normal is 16 times 9.8. It's just the weight of the body. 16 times 9.8 is 156.8. So mu times 156.8 equals to 68, which is the acceleration. But you will have a number there. You don't have tension, but that's okay, because you also have this. 7 times 9.8 is 68.6, right? So here I will put that minus tension, no friction because the mass is not touching the wall. You find the tension here because you will find the acceleration here. You use this acceleration here, here. All right. The other machine we did it in class. And I will go over this problem on the lecture. All right, so I will probably go on over the Webassign on the week 6 video. So this finishes week 5, basically. All right, now you should be on week 6, watching the videos on friction, finishing Newton's laws, and then I'll be uploading one more video on week 6 and starting week 7 a few days after this. Guys, if you have any questions, please let me know. If not, I will see you guys in the next video.